Here's a podcast on about the second half of the notes for atomic structure. We're going to talk about the periodic table and ions and those kind of things. So the periodic table is in general divided up into two parts, and that's kind of the dividing line. And on this side are the metals, and on this side are the nonmetals. And of course, kind of going down this little dark line you see down there, those are the semi-metals. And I have a picture over here of some of the semi-metals. So they're part metal, part non-metal. And characteristics of metals. Metals are malleable. They can be hammered out into sheets. They're ductile. They can be drawn into wires. They're lustrous, which means they're kind of shiny. And they're efficient with heat and electrical conduction. So elements in nature, if you were to just go dig up a pile of dirt, in nature you wouldn't find very many individual elements. You'd find them more likely in compounds because it's more stable that way. Periods. The periods on the periodic table are the ones that go across, maybe in a little straighter line than that. So those are the periods, and in fact there are 7 periods if you count them. 1, 2, 3, 4, 5, 6, 7. And these are 6 and 7 because they actually slip up in there. And the groups are the ones that are going up and down. And they are also called families sometimes because groups, these particular groups on the periodic table, have things in common, just like families do. And it's different numbering systems for these groups. You can see on this top that there's numbers like 1 through 18, or there's an A system and a B system. It doesn't matter which one you use, just pick one and stick with it. So the A groups are on this side and that side, and the B groups are these ones here in the middle. They're the transition elements. So let's talk about the groups. So group 1, if you look at group 1, not hydrogen, though hydrogen is the only nonmetal over on the metal side of the periodic table. So group 1, those are called the alkali metals. So not hydrogen. Group 2 right next to it, those are the alkaline earth metals. Groups 3 through 12, or the B grouped metals, are the transition metals. Group 17, way over here, so we're going to skip way over here to the last column. Those are called the halogens or halides. Both words are used. Group 18, the very last group, those are the noble gases. Noble gases are considered perfect, ha ha ha, but they are non-reactive. They tend not to form compounds at all. And then there, of course, there are the metalloids or semi-metals that go along that little stair-step line. And again, non-metals on this side, metals on that side. Diatomic elements. So you just have to memorize these. There are elements that exist as pairs of elements and not as individual atoms, and they're written like this. The element symbol with a subscript of 2. So these are them, H, N, O, F, Cl, Br, I. And if you look at them on the periodic table, like there's H, and then you do Naf, Klibri. It looks like a 7, but if you count the elements in there, it's not 7 of them. You have to include this one. It looks like a little Nerf gun putting out a dart to grab it. Another way to remember it, you could say, have no fear of ice-cold beer. Ha, so funny. So non-neutral atoms, we're kind of skipping around here to a new topic. These are atoms that have a charge, and the only way an atom can form a charge is by gaining electrons or losing electrons. So if you gain electrons, you become negative. If you lose electrons, you become positive, or you go in the positive direction. So atoms cannot change the number of protons, or it would change what type of atom they are. So if you lose 1 electron, you become a 1+. If you lose 2 electrons, you become a 2+. And you write that as a superscript on the right side of the element symbol. If you gain 1 electron, you're a 1-. If you gain 2 electrons, you're a 2-. If you were to gain 3 electrons, it would be 3-. So if aluminum loses 3 electrons, which it tends to do, what is the charge? You would write Al 3+. If oxygen gains 2 electrons, what is its charge? O 2-. Ions. So there's 2 types of ions. Ion is the overall arching word for that. And there are cations, which are positive, ha ha ha, and there are negatively charged ions that are anions. That was the best picture I could come up with, anion. That dog does not look negative. So let's fill in this chart of stuff, the stuff of science. And it is possibly with ions in it. So we have a symbol of a CS with a plus. That means it has 1 less electron. We don't have any other information here, so cesium, Cs, is atomic number 55, which means it has 55 protons. And the mass number, I've been given no other information, so I'm going to take the mass number from here, which must be 133. And to get the neutrons, you go 133 minus 55. And that is 78. Now, our cesium is not neutral because we have this positive thing going on there. And it means we have one more positive than we have negative, so it must be 54 electrons. I'm writing with the mouse. It's great, isn't it? And is this a molecule, an element, an isotope, a cation, or an anion? It's positive, so it's the cat. So that one is a cation. I'm going to erase it because we're going to keep on moving here. And the next one is protons is 15, so it must be atomic number 15, which is phosphorus. So I'll write a P in there. I would write a 15 down here. Sometimes I like to keep track that way. I have no information about neutrons, so it must be the mass from the periodic table, which would round up to 31. So I'm going to write 31 in there as the mass number. And to find the neutrons, you would do 31 minus 15, which gets us 16. But I see here we have 18 electrons and 15 protons, so we have 3 more negatives. This must be a 3 minus, which would make it an anion. I'm going to just write an for anion. And the next one down, 20 protons means it's atomic number 20, which is calcium. Probably going to barely fit this in here with my fabulous style of writing. So we have 20 protons, atomic number 20. We have neutrons here, so we'll go 28 plus 20 to give us 48 for the mass number. So if I give you neutrons, use that to get your mass number. So that's 48. Don't look from the periodic table. And now I will look at the periodic table. It says calcium has a mass of 40. So this clearly is an isotope because the mass of this one doesn't match what's on the periodic table. And electrons, I have no other information, so it must be neutral. It must be 20. I'm going to erase some of these because it's getting a little cluttered. Chromium, a mass number is 52. Protons must be that bottom number, which is 24, because that's the atomic number. Neutrons is 52 minus 24, which is 20. It's not 20. 28. So it's 28 neutrons. We have no other information about it. It must be neutral, so it must have 24 electrons. So it's not a molecule. A molecule implies that there's 2 of them or more together. It might be an element. It's not. Let's check isotope. Note the periodic table says 52, so it must not be an isotope. It's not a cation or anion. I would just call it an element. So I'm going to stop on the chart. Actually, I'll look a little bit further on the chart. So which one of these would be a molecule? It's this one that would be a molecule. But if you write out the information, you just write it out for one of those I's. So, for example, I is atomic number 53, so it has 53 protons. You're given no other information, so it must be a mass of 127. So you just do it for one of those. You have nothing about charge, that must be 53. Then 127 minus 53, 74. And this would be a molecule. So you'd write molecule over here because it's more than one of those things put together. But again, you do all those numbers just for one of them. And I'll check in real quick with Se2 minus. So Se is selenium. And I am struggling to find Se on here. There it is. It's number 34, so it has 34 protons. And the important part of this one is to notice that you have 2 minus. So you have 2 more electrons, so the electrons would be 36. So I'm going to stop there just so you realize that 2 minus means you have more electrons. Atomic mass. How heavy is an atom of oxygen? There are different kinds of oxygen atoms. Scientists are more concerned with the average atomic mass. Average atomic mass is based on abundance of each element in nature. Mass is not measured in grams because the numbers would be too small. So we use this thing called an atomic mass unit, and it's based on carbon-12. So here is a problem that was on WebAssign in the year I made this podcast. So carbon occurs in nature as a mixture of atoms, of which 98.89% have a mass of 12, and 1.11% have a mass of 13. Calculate the average atomic mass. Again, I'm going to try to do this in fine style without a real writing instrument. What you do is you take that number and multiply it by that number, but you can't use percentages when you do this, so you'll actually change it to 0.9889. So I move the decimal place 2 times to the left. And then we'll multiply it by 12.00. And then we hit equals. So 0.9889 times 12 is a number with a lot of digits, 11.8668. And then we take the next set of numbers, which is that, and notice if it's a number that's less than 10, you're going to have possibly 1 0, maybe more than 1 0 in front of it, times that ginormous number, 13.0035. Oh, there's another 3 in there. 35, and you hit equals, so 0.0111 times 13.00335, and you get a small number because both of those numbers are small. So I'm going to go 14434, and now the next step is it's like a weighted grade. You find this one and then that one, and then you add those two up. Plus 11.8668 plus that other number, and it comes out to about 12.01. You can almost always check your answer on the periodic table because it should match, and this one was carbon, wasn't it? So if you look at carbon on the periodic table, it does have a mass of 12.01 AMU. And I usually tell you how many places past the decimal in these because they're a little, they can be a little persnickety. I think that's all we have to cover. That's just going on into, and that's the review worksheet, so we're good.